about the classwork that we had today, in addition to going over 2 examples from stage 4 of the activity. Stage 4 worksheet is also attached to Podium tonight, and that will be extra credit. So if you want to spend a little time and practice some of the writing equations, you can download the stage 4 worksheet, and that will be due tomorrow in class. I'll grade however many you do, so there's no minimum requirement there. So before we start, I want to go through a few of these examples. These are example 1 and example 2 from the stage 4 worksheet, and talk about how to write equations and rules. Now the key thing to remember is that there could be more than one step. You could be doing more than one operation, and you also could be changing the order of the operations in order to affect your independent and dependent variable of what they're supposed to be. But you're always writing the equation as y is equal to some manipulation of x. So don't forget, y has to be on the outside, x is the independent variable, and needs to be on the inside. So the first thing I'm going to do in order to work on this is think about 4 going towards the number 33. What can I do to get 4 to equal 33? One instance of multiplication that will get me pretty close to 33 is 8 times 4, and that equals 32. And if I add 1, I get to 33. Coming from 33, we know that if we rewrite the equation, I have y is equal to 8x plus 1. And this is true for the first instance in my data table, but what I want to do is check and make sure that it's true for the second instance. So I can have 8 times my x value, which is 5, plus 1. 8 times 5 is 40, plus 1 is 41. And 41 is not equal to what should be my x value, which is 36. So that is where that equation specifically fails. Now, if you go back, once again, what you want to do is start with y and have y equal some manipulation of x. We tried going over the x value by doing 8 times x. Now I'm going to try to go under the x value a little bit. So I'm going to say y is equal to 2 times x, and see if I can go from there. For my first example, 2 times x would be 2 times 4, which would give me 8. And then to get to my correct y value, I need to add 25. So my equation is y equals 2x plus 25. Again, this works for the first instance. Let's see if it will work for the second instance. Y is equal to 2 times 5, which is 10, plus 25 is equal to 35. That is close, but is not equal to 36. Because I'm close, I'm going to just change one little thing here. Instead of 2x, I'm going to go up a little bit to 3x. 3 times my initial x of 4 would give me 12. And then to get to 33, I need to add 21. So the equation that I'm going to write is y is equal to 3x plus 21. Now once again, this is true for the first instance. Will it be true for the second instance? Y is equal to 3 times 5 gives me 15, plus 21 is equal to 36. And when I take a look, 36 is the next number in my table. Of course, you want to confirm the last 2 data sets, but if you do the math, that will be accurate. So your final equation is y is equal to 3x plus 21. Now I know this is a tedious process, but using the operations and rearranging the order and manipulating your coefficient will get you to the correct solution.